Let's take a look at this problem. It says the slotted arm OA rotates counterclockwise about 0 with constant angular velocity of 4 radians per second. And R is given by the equation 2A cos theta. Now, since we know that A is a constant 8 inches, as you can see from the picture that A is 8 inches, we can rewrite R to be 16 cosine theta. And determine the magnitude of velocity and acceleration of pin B. And we're given at the top there that it's in the case where theta is equal to 0.61 radians. So theta is 0.61 radians at the point that we want to calculate everything. And so we're given this information over here, 0.61 radians, angular velocity 4 radians per second, and it's constant, so the angular acceleration is 0. So like on most of these, what we want to go through and just start taking derivatives. So the derivative of this, now remember, it's the derivative with respect to time. So we're going to have to do implicit differentiation. So derivative of cosine is negative sine, but times the derivative of this with respect to t, respect to time. So that's going to give us a theta dot. Now we take the derivative of this, that we're going to have to use the product rule, derivative of the first. And then the derivative of this is going to be theta dot. Times the second, which is the theta dot. And so that's the derivative of the first, which is this, times the second, plus the first times the derivative of the second, which is just going to be the derivative of that theta double dot. Like that. And we can maybe rewrite this a little bit better. Let me just rewrite this as, we can have that theta dot squared cos theta minus 16 sine theta, theta double dot. Now let's substitute everything we have up here and into our equations. So we're going to be working with these equations up here. Again, I guess we've rewritten this one, so it's really just this, this, and this. So we're going to use these values. So R is going to be 16 cos of 0.61. When you put that in your calculator, you get 4. And I guess we're working with inches, I believe. Let me just recheck the original picture here. Yeah, we're working in inches. So it's going to be 4 inches. And then our dot is going to be using this equation here, minus 16 sine of 0.61 times theta dot, which is 4. Put that in your calculator, and it's 3666 inches per second. Then our double dot, minus 16. Now, like I said, I'm going to use this equation here. It's a little bit more concise. Theta dot squared, which is 4 cos of 0.61 minus 16 sine of 0.61. But that whole thing up here, remember, this is kind of all separate. That's all times 0. So this term is just going to be 0. And we put this in to our calculator, we get like 209.8 meters per second squared. Now we have to use all of these together with our equations, and you should have those available on your equation sheet. So the VR, remember, is just R dot, which is equal to up here a minus 36, I'll call it 0.7 inches per second. And V theta was R times theta dot. R was up here was 4. Theta dot is, excuse me, I made a mistake tonight. I made a mistake back here. Could you please fix this back here? This was a mistake. When you put that in your calculator, this is like 13.1 inches. Sorry about that. That should have been 13.1 inches. And so so down here, this should be 13.1 inches. Times theta, which is 4, which it gets around 52.5 inches per second. Like this. Let me pull this up a little bit. Okay, sorry about that. And then so our velocity is going to be negative 36.7 squared plus 52.5 squared equals 63.99 inches per second. And then for our acceleration, AR, again, using the equations on your equation sheet, we have our double dot minus R theta squared is equal to, and what did we get from before? Our double dot, we had minus 209.8, and R, which I had fixed, was 13.1 times 4 squared, which is minus 420 inches per second. And then A theta was R theta double dot plus 2R dot. And R was at 13.1, but actually theta double dot is 0. So that's going to go away, plus 2. R dot was minus 366.7. Minus times theta dot was 4. And when you put that on your calculator, get 293.3 inches per second squared. So just double check that. 3 minus this is that, gives us that. So acceleration is going to be a r squared plus a theta squared, which is minus 420 squared plus minus 293.3 squared, and put that in your calculator, around 512. I'm rounding quite a bit, inches per second squared. And next, we're going to take a look at this problem. It says if arm OA rotates counterclockwise with a constant angular velocity of 2 radians per second, determine the magnitude of velocity acceleration of peg P at theta equal 30 degrees. And so now we're given the equation of the path, which is r squared equal 4 sine 2 theta. And so let's take a look at this problem. So let's take a look at this problem. We're given this equation, and we're given that we want to find the information when theta is 30 degrees. Now you can convert that to radians if you like, if you're kind of uncomfortable working with radians and degrees. So you can multiply that by pi over 180 to give 0.524 radians. And now we want to take the derivative of this. Now, normally we have an r on the left side, but this time we have an r squared, so we have to use the chain rule again. So we're going to take the derivative all the way across. So this is going to be on the left, we'll have 2r, but we're taking the derivative with respect to time. So we have to take the derivative of this, which is going to be r dot. On the right derivative of that with respect to time, that's going to be 4. And then, of course, bring the 2 forward. Well, let me hold that off just a second. Let me make this cos 2 theta. Then again, using the chain, we want the derivative of this. So normally you would take over here, this would normally become 2, but since and then times the derivative of this function, we don't know what that function is, so we just have to call it 2 theta dot. And so let me just rewrite this equation here. And all I'm going to do is rewrite it. Actually, I'm going to divide both sides by 2 and get rid of this 2. So I'm divide both sides by 2. That's going to give us r dot equal 4 cos 2 theta times theta dot. And let me give these equations a name. I call the first one equation 1, then equation 2 gives us that. So let's take another derivative here. So now we have a product, so it's a derivative of the first times the second plus the first times the derivative of the second. So derivative of the first times the second plus the first derivative of the second. Then over here, same deal, derivative of the first, which is going to be 4. Then we're going to get a negative when we go to sine 2 theta. Then we have to use the chain rule again. So this is going to be 2 theta dot right here. And then times theta. So this was right here was the derivative of the first times the second, then plus the first times the derivative of the second. Like that. And so let me just give this one a name, call this equation 3. So now we can start substituting. So substitute into, let's say, equation 1. So we're going to put our values into our equation 1 here, and that's going to eventually give us r. So using equation 1, r squared is going to be equal 4 sine, and I'll use the radian version, 0.524 radians. Like this. Then when you solve for r, find that and take the square root, we get 1.86 meters. Like that. Use also equation 2. And so we'll plug stuff into equation 2. We'll use this one right here. Let me put a little box around that. And so that's going to be r we found from here, 1.86. Now we don't know what r dot is, equal 4 cos 2 theta, 0.524 times theta dot, which is 2. Like that. And see if that all makes sense. Then solve for r dot. And when you do that, you get 2.15 meters per second. Then finally using equation 3 right here. And that's going to be like an r dot squared, isn't it? So then here's r dot here. So put in there and square it. Like this. Plus r times r double dot. We don't know what r double dot is yet. We know what r is. Equal -4 sine 2524. I'm just plugging in here now. And that's all times 2 theta dot squared. And that was 2 squared. So I'm just doing the theta dot and making that, there's 2 of them together, make it into a square. Now, one thing, when we get this last part here, notice that theta double dot is 0. And actually, I forgot to put, please fix that. When you go back here, that was supposed to have been theta double dot was 0 up here. Theta double dot was 0. And then, so when we put theta double dot in here, which is 0, that's just all going to be 0. So take a minute to look at that and see if that all makes sense. So let me write down some of these so we can see what our values are here. So have this. Now let me calculate this over here. And this is like minus 27.71 plus 0. And then 1.86. Bring that over. That looks like negative 32.34. So it looks like r double dot is going to be equal to, when we divide it by 1.86, we get 17.39, and that'd be a negative meters per second squared. So we have all the main stuff that we needed. So let's calculate some things. So we can find our VR is going to be R dot. And we calculate our dot up here. That's going to be 2.15 meters per second. Our V theta, again, these equations are all on your equation sheet. Theta dot is going to be our R, which was up here. times our theta dot was given as 2. And that's going to be, let me put that in our calculator, about 3.72 meters per second. And then you can find the velocity right now if you like. This is going to be the square root of this squared plus this squared. And that's around 4.3. I'm going to round things quite a bit. Then once again, look at your equation sheet for AR. It's going to be R double dot minus R theta dot squared. And that's going to be R double dot we found a second ago was minus 17.39 minus, let me 39 minus R was 1.86. Our theta dot was 2 squared. And let me put that in my calculator. That'll be if I did that correctly, it comes out to be minus 24.8 meters per second squared. And then a theta is R theta double dot plus 2R dot theta dot. And theta double dot, remember, is 0. Plus 2 times R dot, which we found to be 2.15. It's 2.15. And then times theta dot, which was 2. And we calculate that. That's 2 times 2.15 times another 2, around 8.6 meters per second squared. Then A is going to be the square root of this one, 24.8 squared plus 8.6 squared. Put that in my calculator. And looks like around 689. Now we have to take the square root of that. And this is around 26.25 meters per second squared, like that.